Hello guys and welcome to another edition of this video presented by the call. We're still going to be under differentiation, and this time around we're going to take the differentiation of logarithmic functions. So we're going to take the differentiation of log functions. Okay, good. So log functions are normally of the form, maybe we have a log b to the power of this. And what we're going to be seeing constantly in the questions are always going to be in the form ln, maybe x. We're going to see something like ln x. We're going to see something like maybe ln x plus 1, something like this, and all. So where does this ln come from? Ln is simply log to the base e of a certain number, which is going to denote ln b or something. Yes, so that's it. Now let's proceed into its differentiation. Now, whenever you're given a function, let it be this. Let's just take this for the example. Imagine you're given a function ln x plus y to differentiate that. As simple as the formula is going to be, the formula is going to be simply it's y and the x equals to prime of f of x. What does this mean? It simply means that I'm going to differentiate this function over here and write back the function down. That means the answer is going to be some sort of quotient that is going to be dividing itself. That means I'm going to write the y by the x is going to be. Now this means I'm differentiating this function, and differentiating this function, what am I going to have? I'm going to have, let's say, forget about the ln for now. It's just a technique. It tells you that differentiate what is inside here and divide it by this. Then if I'm differentiating this, I'm going to have simply x plus 1, which is going to give me a 1, right? Because here I'm going to differentiate x is going to give me 1, here is 0, so I'm going to have a 1. So I write the 1 of the derivative of this function inside here, and I divide it by the function itself, x plus 1, and that is it. As simple as that. So that's how to differentiate logarithmic functions. Don't be scared of it. So let's take another example for better understanding of this stuff. Imagine you're given a function y equals to ln x plus 1 or on x plus 2. Good. Now, this stuff is a little bit messy because applying our formula says we're supposed to take the y by the x of what? Of f prime of x, all that on f of x. That means I'm going to differentiate all this function divided by all this stuff. But now I'm going to be seeing myself using the quotient rule here because it's some sort of dividing each other. I'm supposed to be using the quotient rule here. But now let me use my algebra to facilitate work for me. This is what I'm going to do. We did logarithmic laws and all, and we know that this can be written as this x plus 1 minus ln x plus 2. Good. It makes work easier for me. Now, differentiating this, I can simply now find its derivative. Let me find the derivative of f of x here. Since we solved it previously, the answer was 1 on x plus 1. And here, you just differentiate here and you divide by this. Minus, still going to be 1 on x plus 2. We're done. You see, if we're trying to do the quotient rule, just pause the video to the quotient rule, you're going to come out with this. It's a new way to solve quickly. And now, what am I going to do? I'm supposed to divide all this by this. But now I have to compress it to make it more simply. That's going to be x plus 2 minus x plus 1, or that on x plus 1 into x plus 2, which is going to simply give me, if I open up here, what am I going to have? This one cancelling with this one. I'm going to have a 1, or that on x squared. Here multiply this x squared, and then plus a 2x from here, and an x from here. That's a 3x plus a 3x. Then plus what? Here gives me an x squared. Here gives me 2x. Here gives me x, and plus a 2. Good. So that's it. And now I can divide it by all this function, which is going to now give me the y by the x, which is going to be equals to 1, all that on x squared plus 3x plus 2. Now multiplying by, because it tells me dividing, when multiply, to simply bring it to multiplication I have to invert these guys, therefore it's going to be x plus 2 all that on x plus 1. Simple. And that is that, which I can still do it as such, box it. You can still try to make the smaller, but I'll end there because it can still be left as such. So guys, kindly pause the video, solve it to really master this stuff. It's really pretty simple. Thanks for watching and don't forget to subscribe.